Yes, sir.
Okay, just you write the title attenuation measurement in optical fiber using this OptiSystem software. Sir, ಅವ್ರು ಓದಕ್ಕಿಲ್ಲ? ಅಂತ attenuation measurement in optical fiber using Optisim. Okay, here generally small introduction about the attenuation. Here definition for attenuation. The attenuation is the loss of optical power as a result of absorption, scattering, bending, and other loss mechanisms as the light travels through the fiber. This is the one simple definition for attenuation. The first experiment, just you practice the experiment to study the length dependence of attenuation in the given optical fiber. For that, you need what are the components required. Okay, what are the available libraries in the given version? Okay, it is available only. So CW laser, you need CW laser 1. Parallelly, you can drag and drop. You can do the experiment. Okay, don't waste your time. Don't waste. Simply watch the experiment and all. Okay, you take one CW laser, one optical fiber, one photo detector pin, and then two optical power meters. Okay, here this is the snapshot of this attenuation measurement. Just you drag and drop CW laser. You set the frequency as 1550 nanometer and set the power to 10 milliwatts. Okay, then we'll take one optical fiber cable. Okay, for the you set the length. The length is just you keep you make the one table again. One table I will show. Okay, this is the experiment. This is what our already this is a pre lab calculation. Okay, we keep the wavelength 1550. You set the length in kilometer here, fiber length here, length in kilometer 10 here, set by 10 kilometer. Okay, before you do the experiment, just you know the procedure. You set the wavelength in laser, CW laser. You set the frequency 1550. You just give the power to 10 milliwatts. Okay, then in optical fiber cable, you know how to vary the parameters, how to vary the frequency, how to vary the power, how to vary the length. Double click on the block. We can get this given window. Just you modify the values. Okay, similarly the optical fiber cable, double click on that. You have to change the length. You keep wavelength is constant 1550. First for length 0.5. Here input power is source here 1. This is a pre-lab calculation. In post, this diagram shows the post-lab calculation, that is the practical attenuation. Here input power is, this is called your input power 210. Okay, before you do the experiment, just to start with one simple frequency and simple power. Okay, here we calculated input power is 1. Just you calculate output power by using optical power meter. Okay, you should connect the scope. What is your simulation shows the power level. You have to find the power level before and after optical fiber. Here before and after optical fiber, you need to connect the, you need to obtain the power level. Okay, similarly the optical spectrum analyzer also you connect before and after optical fiber. Okay, similarly the spectrum of oscilloscope visualizer at the end of the receiver. Here this is the receiver point. At the end of the receiver spectrum of oscilloscope visualizer should be connected. Okay, just a simple diagram. First you drag and drop one CW laser and optical fiber. You connect optical power meter and optical spectrum analyzer is before and after optical fiber. You now you connect photo detector in receiver section. In receiver section, just you need to find the scope, that is a spectrum. You connect spectrum of oscilloscope visualization at the end of the receiver. That's all. The simple thing. Here, no need to change any photo detector parameter. No need to vary any parameter and all. Okay, just you do the experiment according to this table. Okay, first you keep the wavelength 1550. You keep the length, vary the length 0.5 to 3.5. You set the input power 1. find out the output power. Okay, after laser, after fiber, you just note down the power based on the calculation. This is to find the attenuation by using the formula 10 log pi by our p output. That is the output input power divided by output power, and also you calculate this is your A2 by AL attenuation per kilometer. Also you need to find, just you find the average. Okay, this is the second section. It's the post lab calculation. Just you keep the wavelength 1550. You vary the length. For example, you change 10 to 50. 10, 20, 30, 40, 50, 10 to 50 you calculate, you keep the length. Then the input power is 210. You find out the output power. Using the formula, you find attenuation. Also, you need to find attenuation per kilometer, attenuation in the length, because our aim, what is the aim? You need to find the length dependency. So you need to study the length dependence of attenuation in the given optical fiber. Okay, this is the table. Just to note down. Who are all having software, who got output, kindly share your screen so that we can note out your register number. That's all. If there is any doubt, means you can ask.
Sir, once show the table, sir.
Yes. சும்மா ஒரு எக்ஸ்பெரிமெண்ட் ப்ரீ லேப் கால்குலேஷன் போஸ்ட் லேப் கால்குலேஷன் வச்சேன். யா 1550 பவர் வந்து 1 வச்சிருக்கு. அவுட்புட் பவர் மீட்டர்ல பாரு, பவர் மீட்டர்ல அவுட்புட் பாரு. வருமா, நான் செஞ்சு பார்த்துட்டு தான் போட்டுருக்கேன். க்ளோஸ் பண்ணுறேன். அப்படி தேவையில்ல, ஆப்டிமைசேஷன் தானே, அது ஒன்றும் இல்லை. இப்போ நீ ஆப்டிக்கல் பவர் மீட்டர் மட்டும் ஓப்பன் பண்ணுங்க. இப்போ ஒரு ஆப்டர்லாம் இருக்கு. 0.997 நீ போட்டு பாருங்க. இது அவுட்புட் அதுவும் 0 தான் இருக்கா? லென்த் இப்போ 10 போட்டு பாரு. 10 போடு. 10. அதாவது தியரிட்டிக்கல் வேல்யூ இது தியரிட்டிக்கல் பார்ட்டு. அது அப்படியே ஒரு நாள் தான். ஏன்னா 0.9 அப்படி போதில்லை, மில்லி வாட்ஸ் என்ன பண்ணால் கொடுத்துருக்குதுல வருதா? அவ்வளோதான்.
இந்த ரன் பண்ணும்போது சார், இந்த
Hold.
ரன் ஆல் ஆப்டிமைசேஷன் கொடுத்துருந்தேன். அதனால இப்போ ரன் ஆல் கொடுத்தாக்க அங்கே வர மாட்டேங்குது.
இப்போ 1 கிலோமீட்டர் வருது இல்ல?
வருது சார்.
வரும், நான் செக் பண்ணி பார்த்தேன்.
ரன் ஆல் கொடுத்தேன், கொடுத்தா வரல. இதை எடுத்து விட்டு சார் ரன் பண்ணாக்கா எல்லாமே வருது.
அதுனா சார் அதே மாதிரி வருது, ஃபுல் ஸ்க்ரீனு. சரி சரி. கால்குலேஷன் ஒரு அவங்க போட வச்சுருந்தாங்க.
Sir, can I share it, sir? Screen.
Okay, Sai Ganesh, share your screen.
So, now we have to vary the length now, sir. Sorry, something happened.
Okay, no issues.
Sir, 1 minute, sir. It was 1 minute. I'll share, sir. Sir, now it is visible, sir. Sir, is it visible, sir? Okay, sir. Here the input power is 210 megawatts, sir. And output power is 205, 205.2.
Okay, so again, click on the input optical power meter. Power meter.
Power meter.
Yeah.
Yes, sir. Here 210, sir.
210 milliwatts. Everything has a dimension. So you should see that e power minus 3 is equal to 10 power minus 3. So
Yes, sir.
210 milliwatts is your input, but don't close it. Do not
Okay.
close. Click onto the optical power meter after the optical length of some 0.5 meter you had kept. 0.5
Yes, now
kilometer.
we have changed.
No, no,
0.5.
do not change. Go to optical power meter, second optical power meter at receiver. Now keep it as it is. Okay. Now what you do is that vary your optical fiber length as it is. Previously you are done for 0.5 kilometer. Now change it to greater than
1
that.
minute, sir. I'll note these values.
Yeah, yeah. Instant without closing the window itself, instantaneously you can change and run. That's all.
Okay, sir.
Here, what is the specialty of this optical power meter is it shows in terms of power watts, in terms of watts, and also in terms of dBm. You note down the dBm also 23.122. But this table, we are given the table, you need to calculate by using watts. Okay, just you note down in terms of watts and in terms of dB power.
Okay, sir. Now I'm changing to 1 kilometer. Now it has become 200, sir. Sir, up to 3.5 I have done, sir. Sir,
Sai Ganesh, X. Okay, except 3.5 means what, Sai Ganesh?
sir, up to 3.5 I have noted the values.
You are varying the length in terms of 3.5
Kilo-
kilometer or 1.5, 2.5, 3.5. Ah.
No, sir, zero point 0.5 difference I have taken, sir. 0.5, 1, 1.5, 2,
Just
2.5,
you,
3.
just you take the length 10, 20, 30, 40, 50, 60. Okay.
Okay,
Based on
sir.
the table, you can find out the calculation, average, attenuation, and all. Oh, wow.
Okay,
What
sir.
happened? Okay.
Now again I have to vary the length, sir.
Ah, yes.
Directly I'm taking 10, sir. Sir, if we still increase more, it will become 0, sir.
What Sai Ganesh?
Up to 70 I have done, sir. If we still more increase, it will come up to 0, sir.
No. Just to 5 or 6 is enough. Just to find out the average
Yes,
based
sir.
on the
For
table.
50, it came 21, sir.
Okay, no problem. So
Okay,
5
sir.
or 6. Just you need to analyze the power levels before transmitter and after transmitter various by varying the length. That's all.
Okay, sir.
Others can finish means share your screen so that we can note down who are doing efficiently. That's why who is having system.
Sir, can I share?
Sarpika, okay, good. Share.
Sir, for me also same values came, sir.
All are getting same value only. You need to show the screen because the fiber is same, many things same. So that's why. Similarly, Satvika, similarly, you also check with oscilloscope viewer. Okay, here if you connect the power level, we are only finding the power level before and after the optical fiber, and also you check the optical spectrum. What all the changes are done when changing the length. Okay, now you are
Okay.
only you are seeing the power level. Also, you see the optical spectrum. What is the change? What is the reaction when length is changed? Okay, and also you need to verify the spectrum of oscilloscope at the receiver end for each and every wavelength. Okay, just you note down the spike. Here some spike is there now at 1.5. Just you expand this one. 1.550, it has some spike. Just you need to concentrate on the spike. Okay, what values of length it may be varied, and also you don't note down. Okay, no need to tabulate the data and all. Just you need to tabulate the power level also, the power level only. Okay, just you see optical power spectrum analyzer output, and also see the visualizer output at the end, receiver end.
Okay.